afternoon. So our project is the cooling construction helmet, and the team consists of me, Humam, and Abdulrahman. So what I'm going to talk to you about today is the introduction to the idea, the design approach, our initial prototype, our final prototype, and the future aspects. Now, our idea came from, we wanted to make something useful. We wanted to do something like give back to the people, give back to the country, because that's what, as engineers, we study 4 years to do something good. So we thought Saudi Arabia. It's really hot in Saudi Arabia. The sun's out. We only get three months of winter. So we thought about the people that are working in that heat, and we wanted to make something that was useful for them. So we thought about a cooling helmet. Now, the cooling helmet, we wanted to make it function automatically, which is the description of the course Mechatronics. It has to be smart, it takes an input, makes a decision on the output. We wanted to make it user-friendly. And there's a principle called keep it simple, stupid, the KISS principle. So that way anyone is able to use it no matter how smart it is or not. And then we're going to talk about the safety. Now, speaking of safety, there are a lot of health hazards. People have told us if there are any health hazards with fans, long-term exposure to fans, is it going to cause people to faint or something like that? Well, I looked into the studies, we looked into the studies, and we found out that it's only when there's a heat blaze or when it's really hot, and the fan is constantly exposed to it, and it dries you up, it dehydrates you. We made our design in order to avoid this problem, and obviously we looked at similar products. There's nothing in the market that's smart, but there's these what we would call dumb. Now the next part I'm going to be talking to you about is the design. Yeah, go back. So this is just, it uses solar power to just turn, and I think there's an on and off switch button. Yeah, this fan, this is a fan at the start of the helmet. But there's nothing more complicated than that you see on the market. Okay, now, how did we approach the design? Okay. So what we did was first we brainstormed what ideas we could have. Any idea, no matter how crazy it was, we put it in this brainstorm. Then the next step was we separated the ideas. What is, for example, putting it under GPS, putting it under light sensing, temperature sensing, and finally, the application. What can you apply? What can you do in these 2 months? So the next stage was our primary cooling technique, which is convection. So how it works is there's a fan which causes suction. It causes an airflow for the hot air to go out of the helmet itself. And the secondary cooling technique is the fans, which I spoke about, which are going to be directed at the person's head. However, we want to use like cooling packets, which will cool the air before it is directed at the person, so it doesn't dehydrate him as much as the hot air. The final step for the design approach is the logic behind it. So we had to put a certain logic before we can start programming, or else you can't really work on something that's just an idea. You have to put these steps. As you see here, it's just simple ideas such as when you turn it on, it beeps, so it lets you know that the person is wearing the helmet or it's working. The helmet lights up in the dark. The fan turns on after 5 minutes of sensing the temperature. As you see, there's 3 fans. 2 fans work, 1 fan works constantly when the temperature is too high. The other 2 fans work every 5 minutes in order to avoid constant exposure to the air. The next step, we'll talk about the initial prototype. It's very important for us to work as a team. We had to make sure that we could set the boundaries, make sure that we know what we're going to do. As you see here, we made this out of CNC machine. We tried to make it as accurate as possible, and this is where we were working. We'll just show you a quick prototype. If you'd like to see it first. So this was the initial prototype for the helmet. And after that, we wanted to determine how good is our project? How good is our idea? Is it worth making? So we entered the Entrepreneurship Institute competition, which Dr. Awad told you about at the start. And luckily we came out, we won third place and boosted our confidence. We were happy with it and let's carry on going. So we started working on the final prototype. And as you see here, we had to design a 3D model, SolidWorks, in order to have the permission to make the part in building 1. There were some limitations, but we were able to work around it, figure it out like engineers, problem solvers. And then we combined mechanical and electronics, soldering, etc., etc. And then we tweaked the final adjustments. Now we'd like to show you, we wanted to make it presentable, so we added the back for the Arduino holder, and we'd like to show you a live demonstration. So this is live demonstration.
So we have one sensor inside, somebody will be in the on. So we have a light sensor here, let it start and the light turns on. And also there's pressure sensor here and pressure sensor inside. Pressure sensor outside is for the environment temperature. If the environment temperature goes high, then the light sensor here turns on. Sorry, the light here turns on as an alarm to the manager, something to stop working for the workers. And also there's a buzzer that works. The temperature inside it controls the fans inside. We have 3 fans here. And the proximity sensor inside, if you put it on, it goes, and if you take it off,
Are you gonna wear it?
So we set the temperature to be like bed load, it's the effect. It has to be between 50 outside temperature Celsius, but we don't have it here, so we need to use that. And also the internal. So you can see, you can hear the buzzer, so whenever the temperature inside goes up. So it's within this temperature. 37. We set the outer temperature to be lower than what we are able to for the safety consideration. If we touch the alarm, the sensor here, it will be positive. And this is how it works.
Unfortunately, we weren't able to get the cooling pads to make it for the design. We wanted to find small ones, we couldn't really find one, so we wanted to make optimized ones for the future. As I'm going to talk about in the next slide.
Cooling pads are big.
Sorry?
Cooling pads.
Yes.
Usually they are big.
Yes, but the way that there's cooling packs and there's cooling liquid. The way that we want to make it is to make it in such a way that you can attach it and take it off. Inside the fans, like it covers a certain percentage of the fans, not all of it, so to allow the airflow, but it covers a certain percentage of the fan, and it cools the air. It won't be a pack, it will be like, it will have holes in it. Do you understand what I'm trying to say? Like the cooling pack will be designed specifically to let air flow through the fans.
Transport from what principle?
What do you mean?
Provide cooling.
It just cools the air as the fan is distributing the air. I don't understand what you mean.
Convection.
Okay, convection.
When the pads have different kinds of liquids or so, when they are mixed, the temperature drops.
I understand.
Remains low, sometimes this is mostly in medical applications. But then, maybe 20 minutes or.
That's why this is the next step. Yeah, I understand. It will be warm again. But that's why the next step would be for the next prototype would be to research which liquid or which jelly kind of material can last for up to at least 4 to 8 hours. This would be the next step in the research, and if it's not, we'd have to go into research and development to develop such a product. And this is just an idea. We can. There are other methods which we'll look into as well, which is sorry. Yeah, we have actually Peltier coolers, but we we devised that it would be too hot to use the, you would need a really large heat sink for the other side of the pellet. We actually have some with us today. I can show you.
Now currently the fans are switching on and off every 5 seconds. They will realize until they are not 5 seconds. I'm not soaking because I'm looking at it.
This is the pellet screw, and this is the heat sink. You see, it's really large. And this sort of, but the idea about the hats is we don't redesign the hats. We design a product that will just go into the hat so that anyone can buy the product, which is what I wanted to talk about here, which is the newer design that we're looking. This is just an aesthetic design. The idea is to make it from a certain polymer that is quite elastic, which you can bend it into any shape of a helmet, and we would use some kind of adhesive to attach it straight onto the helmet. We're with the Entrepreneurship Institute. We're planning to patent it this semester or next semester, inshallah. And we see that there's a business opportunity for this type of fan. You know, it's not out there. It's not inside Arabia, and we hope to achieve it and apply there and take that opportunity into our own hands.
Okay, thanks.
What is the power consumption?
Power consumption right now is quite large. I don't know the exact power consumption, but we have thought about using solar panels, and that would depend on our client. If the client is willing to pay extra for solar panels, we would do that. However, if not, we would attach a certain battery pack, which would be placed in the pocket, or
Clear to the building.
yeah, exactly. Yeah, something.
But it's not going to be high because the fans only consume 5 watts. So we have 3 fans, so 15 watts. Okay, and we can have a power fan for that. Because the Arduino is not going to be an Arduino, it's going to be a microprocessor.
Which is the idea of here, where all the electronics are put into a small, or minimized, made as small as possible.
Questions? You're targeting the workers with hard hats.
Yes.
What about
I'm targeting their client,
what?
the client of the workers with hard hats.
Yeah, but it's whoever's working.